Assalamualaikum. Welcome to BSI Instrumentation Measurement Online Lecture course. So this is second video recording for chapter 2 error in measurement. In last session we already discussed on objective of today's lecture is to know what is measurement process and what is the process involved. We would also know what types of error, calculate error in measurement, and then understand the common statistical analysis in measurements. We should be able, by end of this lecture, we should be able to calculate the statistical analysis of the measurement data. So what is the measurement process looks like? The measurement process is a process that converts a physical parameter. For example, if you are about to gather a parameter like temperature, voltage, it is a process to gather the physical parameters to a meaningful numbers by using an appropriate instruments. Involve all information, equipments, instrument, and operation related to measurement. Okay, so the input here for physical parameters measured by instrument measurements, and then we will get an meaningful numbers we call as an output signals, usually in electrical parameters. So as discussed in previous lecture, we already mentioned that measurement methods can be classified as direct comparison method and indirect comparison methods. Two methods of measurements. For indirect measurement methods, the comparison is done with a standard through the use of calibrated system, such as measurement current flow using ammeter and voltage using voltmeter. For direct measurement process, we are able to measure the value, the quantity directly. For example, we are measuring the current flow by using ammeter. In comparison methods, for direct measurement has lesser than indirect measurement. So this error depends on accuracy of each measurement instrument. So direct methods is a simple methods of measurement in which the value of the quantity to be measured is obtained directly without any calculations. That means if you're having your instrument measure, for example, to measure your currents, you should be able to get the value of your measurement directly by reading the scales or the display of your instrument. So direct method can be classified in two categories, which is deflection methods and comparison methods. In deflection methods, the value of unknown quantity is measured by the help of measurement instrument having calibrated scale indicating the quantity under measurement directly. Okay, so this is the definitions of deflection methods. For example, measurement current can be done by using ammeter. So the value of your current you can understand by reading the deflections of the pointer here in the display of your ammeter. So this kind of direct method is classified as deflection methods. Another category for direct methods is comparison methods. In comparison methods, the value of the unknown quantity is determined by direct comparison with a standard of the given quantity. For example, a measurement of EMF, electromagnetic force, by comparison the magnetic force of a standard cells. Another example for comparison method is balance scale. This is very old-fashioned of measurement a weight. You put in one pin of your balance, let's say 1 kilogram for a reference balance, and then the object of your things that need to be scaled is put in another pan of your balance scales. Then you can have your value of the weight by reading the measurement in the pointer perpendicular to your balance. So this we call as direct methods by comparison methods. So what is error in measurement? We have understand how the process of measurement took place. Then let us now see what is the error, how does the error come out from our process of measurement. Performance characteristics is the characteristics that show the performance of an instrument. For example, all instruments have the criteria of accuracy and precision. So this performance criteria allows user to select most suitable instrument for a specific measuring jobs. For example, the most important criteria for instrumentation is accuracy. Accuracy is the degree of exactness or the closeness of measurement compared to expected or desired value. Let us see example in these above pictures. So as this is a target for your measured value, and then this is your output. As you can see, your output of measured is gathered towards the bull's eyes. We can say this is have a very high accuracy. And then if it's scattered away from the bull's eye or the objects, so the accuracy is low. So you can have the criteria of your instrument having high accuracy or low accuracy. So the percent of accuracy is actually can be calculated as 100% minus the percentage of error. How the percent, how much is deviate from the object of the accuracy of the target value. Another significant criteria for instrument is precision. Precision of a measurement is a quantitative or numerical indications of closeness, which a repeated set of measurement of same variable agree with the average set of measurement. So let's see how the precision looks like in this picture. In the first example, the precision for this target is high precision. This means that all the target, all the measured value goes into a particular consistent value. And then the second example also, the measured value is very consistent. We can call as this instrument is high precision. Next example, we have scattered value is very deviate, different, is not saturated in a certain value. So the precision is very low. And then we can see another example here. This precision also considered as low precision as all the measurement value is very deviate from the target. It's not consistent at all. Another criteria for instrument is resolutions. When an instrument is showing a particular output readings, there is a lower limit on the magnitude of the change in the output measurement quantity that produce an observable change in the instrument output. The resolutions of an instrument influence how finely its output scale is divided into subdivision. As this example, this ruler having a subdivision and a better resolution compared to first ruler. So this subdivision will give you more precise in your measurement. A better resolution will give you a better precise in your measurement. Next is sensitivity. Sensitivity is another criteria for instruments. Sensitivity of measurement is a measurement of the change in the instrument output that occurs when the quantity being measured change by a given amount. So it is a ratio of change in the output. So how much sensitivity it will give you output. So the small change in the output will have change in the output. So we call as sensitivity. And then expected value is the value that can be obtained from theoretical or a probable value that we are targeted before measurement. Error in measurement. So actually, no measurement can be made with perfect accuracy. There is no such kind of perfect in measurement. If there's somebody come to you giving a perfect data, is actually is a nonsense. So you should expect some error when you are doing measurement. Although it's a scientific measurement, it will still have an error in your measurement because no measurement can be made with a perfect accuracy. But it is important to find out what the accuracy of the measurement and how the error have entered into the measurement. So, study of error allow us to determine the accuracy of the final test result. In order to understand the concept of error in measurement, we should know the two terms that defines the error. First is the terms of true value or expected value and a measured value. So you should be able to understand what is measured value and what is the true value. A true value is a nominal value or a theoretical value. It can be derived from mathematically from calculation by theory, or it can be found from datasheet provided by manufacturer. So this is true value. And for measure value, it can be found out by readings your measurement during an experiment. So from these two, measured value and expected value, you can calculate the error of your measurement. So error in measurement system can be divided into those that arise during the measurement process and those that arise due to the later corruptions of the measurement signal by induced noise during transfer of signals from the point of measurement to some other point. So, error may be expressed either as absolute or percentage error. So, absolute error is given by the equation of expected value minus measured value. So yn minus xn, measured value. And the percentage value is defined as the absolute value of expected value minus measured value over expected value multiplied by 100. So this is the definition of percentage of error. So for example, if you have 5 millimeter expected value and then you measure the length of your object giving 4.5 millimeter, so the absolute error of your measurement is 0.5 millimeter. So the percentage of error should be equal to 0.5 over 5 times 100. It's equivalent to 10% of your error. So that means your error is about 10%. So absolute error giving you 0.5 millimeter. Okay, now after we have calculated the error, now let us see the accuracy and precision. Accuracy and precision of measurement is a quantitative or a numerical indication of instrument that derive from error. So the previous error that we calculated, we can derive the value of accuracy. So the first thing is relative accuracy. So relative accuracy is derived from 1 minus the error. So now example, the absolute error. So 1 minus. So in order for you to further understand, you can pause value this slide of your, okay, you need to measurement. Do yourself. So this example questions, the true value minus in later slides, value I will show you your solutions of this example. Target value. You may pause at any time. So you can get a relative accuracy. At any moment, then it needs for the percentage of accuracy. This example is okay for this example equations. Percentage of given error. You the so true value of a resistor definition. The true value of the voltage is equal to 100% volts minus, and then the measurement of the error voltage. Let's say your percentage of the resistor is 5%. So 100% minus 5%. So you need to calculate the absolute error. 95%. The percentage of error. So your percentage of accuracy and the percentage of accuracy. So your error 5%. Okay, you may pause at any time as may fit for you to calculate. In other words, the answer of this is equal to, okay. So now this is the solutions for the given examples in previous slide. Okay, so as we understand that the expected value is 80 volt and the measurement and the measured value is 79 volt. So for absolute error is equal to the expected value minus measured value. So 80 volt minus 79 volt equal to 1 volt. And then the percentage of error is equal to your expected value or target value, true value minus measured value over expected value times 100, and then you can get 1.25%. So this 1.25% is your percentage of error. So only 1% of is error. The error of your measurement is only 1.25%. And then for relative accuracy is equal to 1 minus modulus of error. So 1 minus this one equal to 0.9875. So the percentage of accuracy is equal to relative accuracy times 100. So you get 98.75%. So this is how much accuracy for your measurement. So we can say that, in other words, you can also calculate your percentage of accuracy by minus 100 from your percentage of error. So you can also get same answer with your derive percentage accuracy from relative accuracy. Okay, so this is how you obtain your analysis of error from your measurement value. So we have understand how to calculate error in measurement. So there are several types, as we discussed previously, of error that occurs random error because of mistakes in the ordinary process of measurement. So during using instrument also, we tend to have some mathematical analysis. So this error measurement usually occurs because of human mistakes analysis of and data. This may be any magnitude. So if you have random numbers mathematical measurement, how do we configure its error, and we can classify approximate the true value of your measurement? Three group of error. This is called as statistical. We have tools. Gross error, okay, that is come from human error. Statistical and among tools, them, sometimes we have median instrument, deviation, adjustment, average deviation, comes from variation, application and variance can cause you some error. So this error we classify as gross error. Very, and then for systematic errors, these errors to get a significant value of our measurement on repeated measurement is error of the given distribution of your measurement. This error can be evaluated compared to previous influence on the results of measurement can be eliminated by the introduction of proper correction measurement. And we, so for example, know the target value in this or the true value. Now what happened here is we do not know the we have a target value or the measured value at certain point. So we need to do so this may be coming from two types of systematical error. So mean. In statistical analysis, the most important item is mean. Mean or arithmetic mean is an average value that can mathematically be obtained from sum of your measured value over numbers of your measurements. Okay, so in mathematical symbol you can have x bar equal to summation of xi over n. N is the number of your repeated measurement quantity and x is your value of your measurement, the total number of your measurement. And then we have deviation. Then so deviation tell us about the departure. Now we need to derive the standard from the arithmetic means
of the data
So
set.
the amount, the standard
This
deviation,
denote as
the amount by
n
which
calculated
n measurement values are
for each
spread
readings.
about the mean is
Okay,
expressed by
so how
standard
much it
deviation.
deviate?
So let's
So
say
how
the
much
bigger your standard
it
deviation,
offset,
it will
we
tell
call
us
as deviation.
the bell
So for
curve
example, if
of
you
your
have
data
if you go
distributions.
through
Let's say your
5 times of
your standard
measurement, so
deviation is
each
small,
measurement
means that your bell curve
you can
has a very
calculate
slim
how much is deviate
kind
from the
of
mean,
graph.
from the average.
Okay, so
So
how
let's say
what is
you
the
calculate
formula
the
to
length
derive
of
the
your pencils.
standard deviation?
So first
So
measurement
standard
is equal to
deviation
5
is coming
5
from
centimeter, 5.5
your
centimeter, 4.5 centimeter. So each
deviation
measurement
power by 2.
you need to
Okay,
calculate how much it deviates
deviation
from your
square
mean, from your average
you
of
sum
your readings.
all your
This we
deviation
call
square
as
and
deviation.
divide
And
by
then
n, and then you
the
square root
average deviation,
this value, then you can get your
we
standard
can
deviation.
calculate the average deviation
Okay,
from
sum of your so
deviation.
in other means,
Okay,
standard
we total
deviation
all
is
the
defined
deviation
at the square root
that we
of
calculate
the sum of
from
individual
this deviation,
deviation
then
squared.
we divide
So
by
divided by the
our
number of readings,
numbers
and
of
it denotes as
your
sigma. Okay,
calculation.
so we
of
have
your
1 sigma,
measurement.
2 sigma, or 3
Okay,
sigma. So this is the
understand?
distribution. Okay,
So n is your
number of readings. So for example, if you have less than 20 readings, so the denominator is expressed as 1 n minus 1 rather than n. Okay, so please note that if your number of sampling is less than 20, you need to use the denominator as n minus 1. Okay,
so
and then
let us do some
variance.
example of
So variance
statistical
is,
analysis.
okay,
For
power
example,
2 is square
an
of
emitter
deviation.
have
So
been
variance
used to
means
measure current
square
value
of your
I,
standard deviation.
which
So
flow through a DC motor circuit at a different
if
time.
you
Measurement
get
result
the value
shows
of
as
standard
in table.
deviation, then
So calculate
you can
average
get your
value for these
deviation.
sets
So
of data,
variance is
and then
sigma
calculate deviation for
square.
each reading.
Okay,
And your
and
standard
then
deviation is
calculate
sigma.
the average
Okay, deviations. Then calculate the standard deviation. Later, calculate the precision of the 6 measurement. Okay, so calculate the precision of number 6 readings. Okay, so you may pause at this slide in order for you to do these examples. Okay, so you may pause this slide. I will share the solution answers for this example in later slide. Okay. Okay, so
now
this is the
calculate the
solution
average
for
deviation.
so
the
for every
previous
deviation,
example.
you sum up
So to
all
calculate
the
the average
deviation of
value
each
of your measurement,
So you total
so you
sum
have 8
up
measurements, so
all
you
the
sum up
data
all the total
and
deviation.
divide by the
So all the
numbers
sum of
of
your
reading.
deviation is
So
equal
you
to
have 8 numbers of readings.
1.5868.
So you divide by 8.
Divide by 8.
You get
Now you get
4.971984.
ampere.
So this is average
And then
deviation.
to calculate
The
so
deviation of each readings.
so
This value
your readings
will let you know that
minus
only
your
1.178
so average is
is deviate
4.97
from your mean 36.
Okay,
So now calculate the standard
5.001
deviation.
minus
For standard
4.9,
deviation, you can use this formula.
0.0274.
You can, please note that the
Same as
denominator I
second
use here is n minus 1
readings.
because of what?
Also,
Because
you can get
your
the
reading is
equation, you can get
only
the
8
answer by minus
sampling.
measured readings
As I said
value
previously,
minus by
if your
average
readings
value.
and number data set
Okay,
is more
if
than
this
20,
repeat
its 4 other
denominator
measurement
is equal
readings.
to n.
But
Okay,
now, in this
then you get
example,
the deviation.
so the
Denominator
deviation
is
square
8,
is
so you
equal to,
use n
you
minus 1.
square this
So 8 minus
deviation,
1.
you get the
Okay,
deviation square.
so you can get
Okay,
0.2559.
okay. Now let us calculate your last question. the precision for the 6 measurement. Okay, so how do we calculate the precision of the 6 measurement? Okay, you have 8 numbers of measurement. So we want to know the number 6 sample, how much precise it is. So how much precise it is, we calculate. Okay, so the measurement of 6, the value is 4.593. So how precise it is? We compare with its median, its mean. Its mean is 4.9736. So 4.593 minus 4.9736 over by 4.9736. Okay, so you can get 1 minus this, you can get 0.9236. So this is how precise is your measurement of 6. Okay, understand? So